This is the AS2 paper for June 09. The topic of this question 2 is refraction. Snell's law of refraction states, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for any two transparent materials. Describe an experiment to verify Snell's law when the transparent materials are air and glass. In your description, you should draw a labelled diagram of the apparatus and its arrangement, and B, describe how the apparatus is used to obtain angles of incidence and refraction required. Firstly, a labelled diagram of the apparatus. We draw a glass block of any shape. The easiest one is a rectangular block. So we have to label it. Glass block. And then we can draw a ray box at any position of our choice. And I would direct it at an angle. To the block. And again we need to label it. And initially I would show a ray directed at the block and draw a normal in. And I would actually show the refraction. It's not necessarily required, but it may help in your description down below. And label this as the normal. And label the ray of light. So we have a glass block with a ray box directed at the glass block at an angle. And we've shown the ray of light, and we've shown the refraction. So the first step that the person needs to do if they're doing this experiment is draw around the glass block and draw a normal at 90 degrees to the boundary. So that's your first preparatory step. The second step then is to direct a ray of light at glass block where it joins in, where the normal meets the boundary. And mark the path of the light ray as it enters and leaves the block. The next bit, remove the block and join up the paths. And now measure the angle of incidence and the angle of refraction. As on the diagram. So we can mark I and R in here, which is in your diagram. If you show the angle of incidence and the angle of refraction, it makes it so much easier in your description. You could then, if you wish, say about repeating the experiment at a range of different angles of incidence to ensure reliability of your results. So that was A and B, all about Snell's law. The data may be analysed by drawing a suitable graph. So you repeat the experiment for a range of angles of incidence and you can draw a suitable graph. Label the axes on figure 2.1 and sketch the graph. Label it 1. So we need to watch out for that label. We're verifying Snell's law, and Snell's law is that sine of I over sine of R is a constant. Now we know that that constant is actually the refractive index for the material. So we want sine I against sine R on our graph, and sine I is divided by sine R, therefore sine I is on the y-axis and sine of R is on the x-axis. Now there are no units for sine I or sine R because the sine function is a ratio, so you don't put degrees on it. That's a ratio, so it's just a numerical value. So it's sine I against sine R, and if we're saying that that's a constant, then we're expecting a straight line through the origin. And this is graph 1. Then part 2 of this section, on figure 2.1, draw a second graph to show the effect of repeating the experiment with a different material of lower refractive index than glass. If it's a lower refractive index, then we're expecting sine I over sine R to be a lower number. In other words, the gradient of the graph is going to be shallower. So we now draw a slope line again through the origin, but at a smaller or shallower gradient, and we label that graph 2. So in this question we were asked to draw a diagram of the apparatus required to verify Snell's law and to give a method for the experiment to verify Snell's law, including the measurements and how to use the apparatus to find the angles of incidence and refraction. Then we were analysing the results by drawing a suitable graph, and we're expecting sine I against sine R to be a straight line graph, and if we have a material with a lower refractive index, the gradient of that is lower.